In this video, I'll demonstrate how to analyze a typical ELISA using the MyCurveFit Excel Add-In. Note the MyCurveFit Excel Add-In is required for performing 4PL analysis in Excel. You can download a free trial of the add-in by following the link in the description. I have open an Excel spreadsheet containing my plate layout and raw data. I've also gone ahead and performed some formatting in preparation for our data calculations. You can download a copy of this spreadsheet for use as a template for your own analysis by following the link in the description. You can see on this first data sheet, we have the plate layout displaying how my samples are arranged on the 96 well plate, with all of my samples run in duplicate. My standards are in columns 1 and 2 from A to F, followed by my blank samples and my control. The rest of my plate has unknown samples from 1 to 40, again in duplicate. We also have the raw data, in this case the optical densities collected by my plate reader. I've also included the standard concentrations in this table, entered from my kit insert. These concentrations will serve as my Calibrator X values. For my assay, a blank correction is performed prior to the standard curve fit. I've added 2 matrices here to house my blank corrected values as well as my calculated concentration values. On the Fit tab, I've created a plot data table and a chart that will populate once we've calculated our fit parameters. And finally, the Sample Table tab will display the results in a table format as opposed to a matrix format. You can see the raw values have already been populated using cell references back to the data sheet. And the blank corrected and concentration columns also contain cell references that will be populated once the data is added. Back on the datasheet, I'll perform our blank correction. Our blank samples are in wells G1 and G2. I'd like to subtract the average of these wells from all others on my plate. So I'll enter the formula by typing equals, selecting the corresponding raw value, minus the average of the blank sample wells. I'll press F4 to denote these wells as an absolute reference. This way, when we populate the rest of the matrix, the same blank samples will always be referenced. Pressing Enter applies the formula, and now I can hover over the bottom right corner of the cell and fill the rest of the matrix. The blank corrected values will be used as the Y values for my standard curve fit. So I'll go to my standard table and calculate the average of each standard to be used in the 4PL fit equation. I'll enter equals and take the average of the associated blank corrected standard wells. So for standard 1, that's A1 and A2. Again, dragging to fill the formula to the rest of my standards. Now we can calculate our 4PL fit parameters. I've created a table here to house the results, so I'll select 4 cells to house my parameters, 1 additional cell to display the R² value, and another column to display the headers. I'll type equals and begin typing my curve fit. For this assay, I'd like to use a 4PL fit, so I'll make that selection from the available options, highlight the X values or concentrations, followed by the Y values or average blank corrected. Pressing Ctrl-Shift-Enter applies the formula. Now, once we've calculated our standard curve fit parameters, we can now calculate the sample concentrations. The sample concentrations are calculated using the obtained blank corrected optical densities or Y values, so for that we would like to calculate the corresponding X value. I'll use the 4PL Calc X function to calculate these values. I'll begin again by typing equals followed by my curve fit and selecting the 4PL Calc X option. I'll highlight the fit parameters and press F4 to make this cell selection an absolute reference. Next, I'll select the corresponding blank corrected Y value, and note that this selected Y value is not an absolute reference, so it will be updated as we fill the rest of this matrix. And now I'll press Enter. Now we can hover over the bottom right corner of this cell and fill the rest of the matrix. So to this point, we have successfully calculated our blank corrected values as well as our final concentration values. Next, we'll plot our curve. On the Fit tab, we'll use the MyCurveFit 4PL Calc Y function to calculate the Y values corresponding to the X values I've already entered. For more information on how to create a plot data table and chart the resulting fit, please see the video available in our free training course, link in the description. But briefly, I'll enter an equals, followed by my curve fit. I'll select 4PL Calc Y. I'll go back to the Data tab to highlight my parameters, pressing F4 to denote an absolute reference, and select the corresponding X value. Pressing Enter applies the formula, and again I can drag down to fill the plot data table. So here you can see our data plotted on the chart. Typically, ELISAs are displayed on semi-log axes, so if you'd like, you can right-click on the axis and select to Format Axis, and here you can select a logarithmic scale. And finally, on our Sample Table tab, you can see that because we've already added the cell references, the sample table has been automatically updated to display the results. To demonstrate how to add the cell references, I've left the control sample blank. So on our Data tab, we can see that the control samples are in wells H1 and H2, or the bottom leftmost cells in our matrices. So in the sample table, I'll press Enter, go back to the Data tab, highlight the raw values, and press Enter. I'll do the same for the blank corrected values and the concentration values. And to this sample table, we can also add further calculations. For example, I've added the average concentration as well as the percent CV. We can also add dilution factors to calculate the final concentration by adding another column titled Dilution Factors, entering the associated dilution factors. Next, we can add a column next to the average concentration and name it Conc times DF, and multiply the average concentration times the dilution factor. And this will display the final concentration. So as you can see, we've calculated our results, plotted the fit, displayed the results in a sample table, and added some additional calculations. This configuration does take a little extra time to add the cell references and formatting, but you can use this spreadsheet as a template for additional analyses. For example, I have another set of data for this same assay that I'd like to analyze. So I can copy and paste that data directly into the raw data matrix on our Data tab. And as you can see, the blank corrected, fit parameters, and concentration values are all automatically updated. The fit is also updated, as well as the values in our sample table. If you have any questions about how to analyze your ELISA using the MyCurveFit Excel add-in, please email us at support@myassays.com.